Okay, so today we are looking at triangle congruence by side, 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 and side angle side. So SSS is side, side, side. SAS would be side angle side. What we're looking at is to prove two triangles congruent using these two methods. So the very first theorem or postulate you can write down, postulate 4.1, I would rather, you can have the number on there, but I would rather that you use side, side, side or SSS to say what you're using. I do not have the numbers memorized, and I think it's easier to just memorize the letters. What I would like you to write is just the words. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the two triangles are congruent. So here is a proof, I assume, yep, that has 3 steps. Super, super easy, super, super simple. I would write a few of these down so you have sample questions. They never do the same picture. They never do exactly the same given. So it's not going to ever be exactly the same necessarily unless I pick exactly the same one that we've done. But at least it'll show you what you need to do to get to the end. They don't take very long, and I feel like of all the proofs that we have done or will do, these are the very easiest ones. And a lot of students do not have trouble with these at all. The letters kind of tell you exactly what you need. It's just looking to see what you can get. So the given is LM congruent to NP, NM congruent to LP, and we're going to prove that the two smaller triangles are congruent. All right, so first box is going to be the given, LM congruent to NP. And NM and LP. Also, the last step, LMN congruent to NPL. We don't know the reason. So really, even if you had no idea what you were doing, you would get 3 out of the 6 points right here, which is pretty good. You got a 50% already. So I'm going to make this a little smaller or move it down a little bit so we can see the picture at the same time. Now they have everything marked that that should be there. So we are trying to prove this using side, side, side. So it's not the actual proof of side, 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 so we can actually use it. So if 2 of the sides are already the same, what is the third side that we are missing? That isn't marked yet. LN. And it seems weird, but you're going to say LN congruent to LN because it is one side of the triangle on the left, and it's the same side on the triangle on the right. So it seems weird, but that's what it is. So we are missing LN. And this is the only time that I will let you put the letters like the same order. If you flip it, it really doesn't look like reflexive, even though it is. So since this is exactly the same thing on the left as it is on the right, I'm going to put my reason as reflexive. I don't need property, I guess. Congruence. Reflexive property of congruence. If you switch the letters, I'll still give it to you, but most of the time your letters do have to match up, except when you're using this reflexive property. So do we now have the third side? We do, and the triangles have been proven the same by side, side, side. So much easier than some of the other ones we've done that are 6 to 8 steps, and they're kind of going all over the place. Very, very straightforward. So let's do another one. I guess we'll do side angle side once we have it. So here's your second postulate of the day. Again, this is postulate 4.2. I would rather that you use SAS. If you know what SAS stands for, you never have to write it out, and we'll do just the words. Here's what it says. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so here's a second example using side angle side. This one says, what other information do you need to prove triangle DEF is congruent to triangle FGD? So this is kind of a proof, but they don't necessarily request it in a two-column format, so there's nothing below it. They're just looking at it going, okay, if you want to do side angle side, what else would you need? And before we do that, we're going to go back to this picture so I can tell you what that included angle means. So when you look at this picture that's in the middle here, you have side AB is congruent to side DE. That makes sense. Side AC is congruent to side DF. What they're talking about, this included angle, it means when you're looking at one of these triangles only, the two sides that are marked, it's the angle in between them. It's the angle that makes those two sides even happen. Okay, so if you were just strictly looking at this angle, AB would be one side of it, AC would be the other. So it's not going to be across the triangle, it's going to be right in between those two sides that are given. So that's what an included angle is. So in this one, they want this triangle that's kind of on the upper left congruent to the triangle that's on the bottom right. The easiest side that you're going to have is the reflexive side. So even if there's nothing else that you know how to do, always look for sides that are over top of each other or right next to each other. So in this case, it's going to be, we have to have FD congruent to itself. That would be another side. If you looked at side ED and side FG, there's no way at this point, without knowing the one that's touching itself in the middle, that would even happen. So that definitely is one that if you don't have a reason that ED and FG are the same, you can't do that. You have to look for something else. So first of all, we're going to say FD congruent to FD. I'm just going to put reflexive property of congruence. We'll go reflexive congruence. So we have two sides. Where should the angle be? Should it be, I'm looking at only the top triangle. Should it be angle D, angle E, or angle F? Which is the angle that's in between the two that I already have marked if I only look at this part? Which angle do I want to pick? Which angle is included? Any guesses? There's only 3 choices. Take a guess. Which one? E. So she's saying this one right here. Is E in between the two sides that I have marked? That means it has to make up that angle. It isn't. So I'm going to have you guess again. F. Yep. So when we're looking at F, I'm going to change colors so I can kind of show you. This side is marked already. This side is marked already. The one that makes that angle even happen is right there. That's what an included angle means. So that's the one that we need. Okay, so we're going to do angle EFD congruent to angle, should I say GFD or DFG? F has to be in the middle. Actually, what did you say? FDG? I think I said it the wrong way, didn't I? I said DFG, and you said FDG, which is right. Okay, I said it the wrong way when I said it. What you're looking at is you need this angle right here and this angle right here, the same. So you need the included angles in both of them, and that's really the easiest way to do it. So in the one on the bottom, the way that you picked that one out is this side right here and this side right here are the ones that are given. This is the one that's included. So those are the two that are the same. So I'm going to say FDG. Wait, EFD, GDF, sorry. GDF. You can also tell by the angles at the beginning if you have the order right. Okay, so let me show you how to do that. If I say E, F, D, I start in the middle, I go to the letter on the right, and then I go back. So the letters that you should write are also in that exact same order. So you start with the letter in the middle, you go to the right, and then you go back to the one at the beginning. So it really goes E, F, and then D. You have to go G, D, F. It has to be exactly the same order, and that's another way that you could get the right order there. Here we would say that we would need those two things in order for us to use side angle side. This one isn't a proof, so you don't necessarily have to give reasons, but you do have to give the actual items that you need to make it the same. Okay, what other information do you need to prove LEB, the one on the top, is congruent to the triangle on the bottom? So what's the reflexive part that I need to write down? The side that either overlaps or is next to something in the other triangle. Reflexive, what do you think? Perfect. Okay, so what edge touches the other triangle, side by side? So LB is congruent to itself. So we have a side and we have an angle. So I'm only looking at one triangle when I'm doing this. So I'm going to look at this one that's on the top. It's harder to look at if you're trying to do both at the same time. So I have a side and an angle already. And remember, the included angle has to be between the two sides that you pick. So which side would be on the other side of the angle? Would it be LE or EB? If I want to use side angle side. LE. And then I'm going to have to plug this thing in. Hold on a second. Okay, so we have LE congruent to which side in the bottom triangle? And the letters have to be in the right order. NB. So we can also check it out. If we have LE, that's the first two letters of the triangle congruent statement. And do I have the letters right? Did you say NB? Do I have them right? Got to switch them, right? Just switch them around. So right letter choice, but the order of the letters is wrong. So I'm going to go BN. Okay, there we go. Okay, and that would be your side angle side. So when you're looking at it, you have this side, the angle in the middle, that side. That's the order that you want to have it. For the other one, the angle would be this side right here, angle in the middle, and then that side. So same exact order. The letters do matter. Okay. Would you use side, 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 or side angle side to prove the triangles congruent? If there isn't enough information to prove them this way, write not enough information. Explain your answer. So with the first set, when we're looking at it, do we have all three sides? They're not touching each other so that we don't have a reflexive thing. So it's not an automatic. So it is not side, side, side. Okay, the next thing you have to check is it side, angle, side? And I only look at one triangle when I do this. I'm looking at side, angle, side. They have to be connected. You cannot jump across to do a side. It has to be all in one continuous kind of motion. So is this one side, angle, side? Yes. So we're going to go side, angle, side. Okay, we don't have to necessarily explain it if it's right. We have to explain it if it's not right. Okay, let's look at another one. How about this one? Is this one side, side, side? And the easiest one to start with is always the side, side, side. So when I look at it, and we should have looked at the other one too. Is this one side, angle, side? Yeah, looks okay. It looks like all you'd have to do is reflect it over and it would look exactly the same. What about this one? I have side, angle, side. But when I look at the other one, do I have that same thing? I would have to go side, angle. I'm missing this side right there, right? So that's what you would say. You're going to say not enough information. Let's go like this. Oops. Not enough information. Missing this side. Okay, if you just want to draw an arrow to the angle or side you're missing, that's probably easiest. They haven't put any letters on here, so you couldn't say you're missing side AB or anything because there's no letters. So the best thing is to just put an arrow and just say you're missing this side. This is the one you would need. How about this one? And then if I reflect it, does it look exactly the same? If I just flip it right over. So this one is side, 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 and it does work. You're not missing anything. How about this one? Okay, now this one back here, yeah, that one worked. If we go with what is marked, what is it? Yeah, so when you're doing these, always go with the things that are marked first and then kind of do some investigating after that. So we're going to do side, side, side. And if you look at this one, you can't just reflect it over. You actually have to kind of spin it, like turn it. If you turn it like counterclockwise about 180 degrees, you'll have it. Okay. Now, if we didn't have any, letter order or anything, these angles in the middle would match, wouldn't they? And then you could use a side, angle, side. So I wouldn't do anything that isn't actually marked unless you have to find things that are the same. If they would have left, like for instance, side 3 off, then it would have been side, angle, side. So use the markings and go with just the one that makes sense. How about this one? And really pay attention to the number of marks that are there. What I'm looking at is this. On this one, I have that, correct? It's between the 1 and the 2, that angle. Is the angle that's between the 1 and 2 the same over here? No, but it does have all 3 sides there, right? So this one, I would say not enough information. Or if you're just going strictly by the markings of the sides, then I would say side, side, side. Okay, so I'm going to do this one in a couple different ways. Let's see if we can rotate it to be the same, though. We should, if we rotate it counterclockwise, it looks like side, side, side. When you're looking at, I'll go not enough information for side, angle, side. Missing that angle right there. And you could draw a picture of it and show it that way. So I would say this one has to be side, side, side. Huh? Yep, if you rotate it around, it would look okay. And that's it. So these are a lot easier proofs and descriptions and everything, I feel like, than the stuff that we've been doing up to now. So I think you will do pretty well on these. And I'll put your assignment up here on the board.